Good morning again. Thank you to the authors to be lined up. Sorry for the delay. We have a technical issue, so I'm sorry for the room. You will not be able to see the slide of all the speaker for the time being, or intermittently maybe. But don't worry, the speaker will be there, so listen to what they are telling you, and you will then have the possibility to see their posters in the next room. And so we will start now with a bit of delay with the first speaker of the morning. And don't forget to vote for their posters with the app.
Yeah, okay, thank you very much. Hello, my name is Konstantin Schaar from the Institute of Meteorology at the Free University of Berlin. And now you can also see my lightning talk slide. So I'd like to invite you to my e-poster session where I will speak about the simulation of atmospheric transport of beryllium-7 and the near-ground concentration of beryllium-7, and especially a comparison of these simulations to data from the CTBTO IMS monitoring network. So what we have is a couple of stations that are measuring the near-ground concentration of beryllium-7, and we compare these data to our simulations, which were like transient simulations for the time span of 1850 to 2100 with a certain climate change scenario SSP 3.7. And yeah, from that we're trying to validate our simulations as well as learn more about the data and maybe look at potential applications of the data and so on. So if you're interested in that, join me at the e-poster session. Thank you very much.
Good morning. I'm Lee Glasgow from Lawrence Livermore National Laboratory, and I am presenting on multi-scale modeling and a capability for predicting flow and transport over complex terrain, taking into consideration multiple domains. This presentation also includes a validation test that was used for the modeling, and it's part of the test series for the Low Yield Nuclear Monitoring Project. And after the first test series, we have concluded that we have confident predictability for large-scale synoptic flow conditions with this model. And we are still predictive, but less confident for locally driven flow conditions. So please come by my poster. I'm at station 3. Thank you.
Good morning, everyone. I am Christopher. I work on the Chilean Nuclear Energy Commission. So in my country, we have 2 infrasound stations in the Pacific Ocean, one in the middle of the Pacific, in Rapa Nui Island or Easter Island, and the other one around 650 kilometers away from the continent. So when the pandemic crisis was happening, some restrictions were forced, and the principal entry into the islands are by airplanes. So I was seeing if you can spot a difference from before, during, and after the pandemic, because you couldn't fly there. So if the data shows something. You can find me on board number 5 if you want to ask me something. Thank you.
Good morning. My name is Elena Golikova. I represent the Institute of Atmospheric Physics in Moscow. My poster is devoted to the study of the significant differences observed in the temporal variations of the parameters of infrasound during the passage of warm and cold fronts through the networks of receivers in the cities of Dubna and Moscow. The filtering signals from warm and cold fronts in different frequency ranges makes it possible to reveal the transition from internal gravity to infrasonic waves by analyzing a sharp increase in their horizontal phase speeds. Thank you very much.
Hello and good morning, everyone. My name is Arthur Macedo from University of Brasilia, and our study is based on aurora detection from the 13 IMS stations on northern hemisphere and southern hemisphere, and we try to discriminate these events on the IMS stations and the DTK software. Thank you.
Hey, good morning. I'm Sean Stava from Pacific Northwest National Lab. My poster today is on the design of a real-time radiation sensor network for atmospheric radio tracer experiments. So we are instrumenting a series of atmospheric transport experiments to refine meteorological models in complex terrain at short distances. So we collected data using an array of 22 real-time radiation sensors that were dispersed over a 5-kilometer region. Each one of these sensors has automatic data collection, is solar powered, sends its data up to the AWS cloud via a cellular hotspot to a web-based dashboard that we have displayed on the screen there. And we successfully deployed and operated this over 4 radio tracer releases. So please come and visit poster 1.1-491 at board number 9 later this morning. Thank you.
Good morning, everybody. My name is Antipka. This one is first, okay. I'm also still a PhD student, so this work is for my PhD work. And we discovered, or colleagues of mine discovered, inconsistency in the wet deposition field with the FlexPart model a couple of years ago. And during the last years, we did a couple of things to improve this, like new disaggregation schemes, cloud diagnostics, interpolation, of all relevant parameters. And I would like to invite you to my poster to see the results of this. And I don't remember, it's either board number 10 or 11. So you're welcome to discuss it then. Can you, next one? Next one, please. Thank you. So this is actually work I do at the CTBTO. And I had a poster yesterday already for high resolution stuff with the DPRK test site. And here I investigated a bit more the relevance of close by source and receptors. And you can see, for example, in DPRK, there's a very complex terrain with mountains. Also in the middle of the European, in Germany and Belgium, we have very complex areas. And I did a couple of studies to see how the high resolution ATM we are trying to use now influence this area. So come to my poster to see the results for this. Thank you.
Hello, good morning. My name is Lucy Bakels. I'm working at the University of Vienna. And today I'm presenting a new release of the Lagrangian atmospheric transport model FlexPart. And in this new release, we focus mainly on improvements in the accuracy, both numerically and physically, in shape and vector position, as other people will present. And in the speed and memory efficiency. Then also we looked at to reorganize the code a bit so it is easier to modify for new users, and added some new user features. So I hope to see you later, and thank you for listening.
Good morning, my name's Susan Ledbetter and I'm an atmospheric transport modeller at the UK Met Office. So in order to model the xenon background, we use atmospheric transport models and they rely heavily on the quality of our numerical weather prediction models. And so it's really important that we understand the uncertainty in those numerical weather prediction models. But as we progress, the complications, the weather projection models that are ensembles are getting more complicated. So I'm going to be presenting just a single example of modeling just one single background emitter using an ensemble model. Thank you.
So good morning, I'm Konstantino Listovsky and I work at CEA where the French NDC is. So here we are interested in understanding how cyclones may be a source of coherent noise and infrasound stations. And so we've been using the expertise of Laboratoire de Météorologie Dynamique who documented Mediterranean hurricanes. And so with this study we try to explain which of those are detected, which of those are not detected. And interestingly, we use other data sets to compare with the infrasound detections, namely lightning detection network, the Woolen network, and satellite observations documenting deep convection. So I'm happy to discuss with you about this poster later. And now I have another e-poster. So different topic, higher up in the atmosphere, gravity waves. So as you may know, gravity waves deeply impact infrasound propagation. And here we are using simulation outputs from a numerical experiment led by Japan and Germany, the Diamond, which basically run simulations at a very high resolution without parameterizing gravity waves. And we're trying to assess by filtering them out or keeping them in the model, what's the effect of gravity waves on transmission losses across the IMS. Thank you very much.
Yeah, good morning to everyone. I'm Daria Tats, and I'm really happy to present our study about the impact of the shape of particle on its atmospheric transport. And as you may know, the radioactive particles, they have a variety of shapes, from small-sized crystalline particles to large amorphous aggregates. And often this variety of shapes is ignored in atmospheric transport models. And this can lead to large inconsistencies between the ground-based measurements and the atmospheric transport models' outputs. So in our study, we propose a new shape-corrected parameterization scheme constructed by experiments and implemented to the Lagrangian particle dispersion model FlexPart. And with this new shape correction scheme, you can prescribe the shape of the particle and the orientation of the falling of these particles. And we did the sensitivity studies with FlexPart to understand how the atmospheric transport differs for very elongated cylindrical particles and volume equivalent spheres. So results are incredibly interesting, and I will be happy to see you at our poster 749 today later. Thank you.
Okay. Good morning, everyone. My name is Pascual Campos, and I'll be presenting in my poster a study that was done during 10-year period on aerosol optical depth over 5 most densely populated cities, provinces in Angola. And we also did a study on the possible influences of the emissions from the Nyamura Jira volcano in Democratic Republic of Congo over the selected cities. So if you want to learn more about this work that we've done, I invite you to join me in my poster. Thank you very much.
Namaste and good morning. I'm Ram Prasad Regni from National Atmospheric Resource and Environmental Research Laboratory, Tiruvana University, Nepal. As you know, Nepal has no nuclear facilities, and the regional background concentration of radionuclides are not also monitored as well. However, the dynamics of the atmospheric dynamics of the region suggests that it transports and deposits the regional radionuclides, pollutants up into the Himalayas and deposit there. Our recent observation of vertical profiles of aerosols and meteorological fields over the river valleys of central Nepal Himalaya and subsequent backtrack calculation suggests that Regional pollutants or radionuclide particulate pollutants are actually transported up into the Himalayas and deposited over there. For more details, please visit to our e-poster. I'll be very happy to answer your questions. Thank you.
Good morning. My name is Jelle Assink. I'm from KNMI in the Netherlands, the Dutch National Data Center. My poster will be on forecasting infrasonic noise levels at ground-based infrasound stations. And for this purpose, we make use of high-resolution weather forecast models. The reason why we do this is because these models give us a good insight about the turbulence levels on the ground that are experienced by the microbarometer stations. And we make use of the weather forecast models, but also of our observational setup in the Netherlands that consists of a 230-meter high tower that gives us great insight in the turbulent motions in the boundary layer. Thank you.
Good morning. My name is Abdel Halim Zawi from High National School of Technology, Algeria. This work deals with the modelization of time domain electromagnetics. We use the finite element method for the direct model, where the geometry is meshed by triangular mesh, and taking into account the cylindrical symmetry of the problem, we can have a fast two-dimensional model. The input for the direct model are the different layers of geological underground and their height, and the output is the induced voltage in the receiving loop. Since we have a fast direct model, the inverse model is based on iterative solving of the direct model in order that the measured signal fits with the proposal solution. For more details, I invite you to see my poster, board 8028. Thank you.
Good morning. We're going to make a small announcement. Please, when you visit the posters you're looking at, don't forget to vote on selecting your favorites. Everybody that has downloaded the app has a function there on scanner. So you can scan the posters and give your best scores to those you wish. Thank you. We go on.
Yeah, good morning. My name is Omar. The OSI is critical and the last component of the CTBTO verification regime. So at the time when the treaty enters into force, we need not just experts in the form of a human resource, we also need equipment with modern and up-to-date technologies. So the aim of this talk is just to review some approved equipment that may be obsolete or that will be obsolete in the future, and then make necessary recommendations. So if you are interested in my curiosity, you can visit my poster during the 3.1 session. Thank you.
Hello, everybody. I am Ahmed from Egypt. My poster today about the magnetic measurement field for on-site inspections. The idea of the posters came during the workshop for the first list of equipment for on-site inspections techniques. I am trying to address some questions addressing the limitations and the capability of the magnetic field measurements in the on-site inspections using theoretical and some case studies and comparing some of the commercially existing magnetometers. So if you are interested in these topics, please visit my posters on board 33. Thank you.
Good morning, everybody. As part of the current OSI program of work, we have a project to determine the relative merits of unmanned platforms, that's ground-based and airborne or near-surface platforms. This poster talks about work we've been doing recently on near-surface platforms using a magnetometer. But we also have work upcoming on the use of ground-based unmanned platforms. And if you come to the OSI exhibition, you'll see a good example of that. So please come and see the poster and the exhibition. Thank you.
Good morning. It's a beautiful day for flying and to conduct an airborne magnetic survey. Airborne magnetics is one of the techniques allowed by the treaty, and we have been trying it during many times. It works, but with many, many caveats. So we have to change completely our philosophy, the way we have been doing airborne magnetics so far. Why not, as Alex just said, to use remotely controlled platforms? It's not an alternative to air flights. It's an alternative, as you can see, to ground surveys. So please come take a look, and you will see the forward modeling we did in the last years and some images about the data we collected with remotely controlled platforms. Thank you.
Good morning, everyone. My name is Kiloni Shah. I'm a PhD student at the University of Texas. So this poster, we're going to be talking about a fleet of portable modular gas samplers that we've developed and talking about the design and build process that we went through, as well as the deployment that we did in a radioactive tracer release field experiment. So please come see my poster at 11. Thanks.
Hello, my name is Emily Gordon. I'm from the University of Texas at Austin. As you just heard from my colleague, Kaloni, a team at UT has developed a system of air samplers that can be used in an OSI context. We also conducted a modeling study, looking at the effectiveness of sampler network density in detecting xenon-133. We used the ATM tool in Line Wharf High Split to do this study, and we looked at the number of samplers, so, release date, release duration, and sample collection interval. If you want to hear about the results of this study, please come by my poster later today. Thank you.
Hello, everyone. My name is Valentine Wangari. I am a master's student in Kenya in an institution called Dedan Kimathi University. So my poster is about the implication of geothermal reservoir modeling, which is something I do in OSI drilling. So you want to make OSI drilling faster, more efficient. So yeah, so it will help in informing the data-driven decisions and optimization of OSI drilling plan. Yes, my poster number is 39. Please come and get more information on this. Thank you.
Hello, good morning. I'm Emilia Koivisto. I'm the Geophysical Techniques Officer in the OSI division and presenting a poster on behalf of the OSI team on some recent exciting advances in geophysical techniques. We had a field test in a mountainous region in Austria last fall, where we were testing a full range of geophysical techniques for deep applications. One highlight was, for example, our new active seismic system. So please come and talk during the poster session, the poster number 40. Thank you very much.
Hello everyone, my name is Remy Kobalkini. I work also within OSI division as a technology testing engineer. Today I will present you a poster about a telemetry system. One of the big challenge for an on-site inspection is the dimension of the inspection area. So we come up with a solution for data transmission to save time and human resources. So it's a nice solution, self-sufficient in terms of power, robust. We can carry the trailer up to some difficult areas, and then we can collect the data remotely. So come to my poster, I will tell you more about this telemetry system. Thank you.
So, good morning. My name is Roland Prochet. I'm from the University of Bern. And I have two posters to present. And one is about argon-37, which is an OSI-relevant isotope. And the gas is sampled in the shallow soil zone where the natural background is high. And this background is a result of cosmogenic production and the rate of which the argon-37 is released to the soil zone. And whereas the latter is, the first is very well constrained, is the latter not. That's why I show some new results on that on poster 42. And on the second poster, I talk about the combination of argon-39 and argon-37. If argon-37 is produced in the underground, argon-39 is as well. And I will show some results of argon-37 to argon-39 ratios measured and also calculated, and compare the natural background with the signature of an underground nuclear explosion. Thank you.
My name is Marco Walter, and I am the managing director of the company Sonicona. We develop software for seismic data analysis for very challenging situations. So we want to give you an introduction to our approach of dealing with forensic seismology, that's how we call it, whenever you are faced with situations where you have very, very weak signals, for example, for the sums of the OSI, or for induced seismicity, landslide monitoring, icequake monitoring. We have found or developed a very specific solution for seismic data event screening and event location, which we would like to present. Thank you very much.
Good morning, everyone. That's not my poster. Good morning, everyone, again. I'm Robin Riedman. I'm working for the OSI division for CTBTO, and we're working hard on developing better flight pods for rapid deployment, where we house our noble gas sampling systems, a xenon, a sonar system, and I'll happy to discuss with you the newest results or the latest improvement wishes for our flight pods for rapid deployment. Come visit us at the poster 634. Thank you.
Good morning to everyone. After on-site inspection, usually a large number of samples have to be measured. In the radiometry and the noble gas laboratory at the NEA Research Center in Bologna, Italy, We have developed a new multi-sample holder with 13 positions that allows to analyze several samples at the same time. The sample can be grouped together by same homogeneous composition or, for example, same provenance. And we have calculated the efficiency of the radio gamma detector for a sample placed in different positions. Thank you.
Good morning, everyone. I work at the International Atomic Energy Agency Department of Safeguards, and I'm here to share with you today experiences of the use of GDI, Geo-Based Data Integration Platform. This is an interactive map-based platform for IAEA on-site inspectors, headquarters analysts, and their managers to access, use, and share geospatially referenced information about nuclear facilities, sites, locations, and activities as we verify the implementation of states' safeguards agreements. GDI is only accessible in a secure environment in IAEA headquarters, but and of course the information is confidential. But I prepared a brief series of slides to give you a sense of what it's like for a team in the IAEA to prepare, conduct, and evaluate the results of an on-site inspection. Thank you.